Okay, so at the end of the last video we completed our ambient occlusion or diffuse shadows pass. In this video I'd like to combine it back with our diffuse lighting pass and discuss why at the moment our ambient occlusion pass as it stands isn't quite what I'd like for our shadows. We can then talk about how we can modify that pass and also the resultant passes that we get, what their uses, if you will, are in terms of the final composite and how we can use each in turn to tweak different properties of our diffuse lighting. So let's jump over into Houdini, and I want to grab a composite view. I also want to bring back our network editor down here, and let's make sure that that network editor is indeed browsed to the composite view. So let's just make sure that we are over in the composite view, and I'm going to bring in some files. So I'm going to push the back tick, and that's taken me over to the object level. So let's just make sure. Well, the first thing I need, of course, is an image network. There we go. And now inside the image network, let's push back tick. Fantastic. So I want to bring in our AO, diffuse light, env light no shadows, and env light no texture files into our compositing network. If we take a look at our diffuse lighting and our ambient occlusion, they are effectively our light and our shadows, and they should, in theory, when combined back together, give us an image that looks like the environment light rendered diffuse lighting pass. Now we saw on the whiteboard that to combine diffuse lighting and diffuse shadows, we're going to multiply them together because we want to take the lighting information and we want to basically say that wherever we have lighting and shadow, we're going to darken that lighting down based on the shadow, but wherever we have lighting and no shadows, we want to leave that lighting intact. The multiply allows us to do that. So I'm going to right click on the output of our diffuse lighting class and create a multiply, which I'm going to wire AO into the second input of. And if we take a look at this, we have a very different pass to our environment light no texture, but we do indeed have light and shadow information. So they're very different currently, and let's take a look at why. There's actually a number of different reasons. And the first area I want to look at is our diffuse lighting compared to the environment light no shadows. So I'm going to shift select that. Our diffuse lighting should be our lighting without shadows, and we saw when we rendered from our environment light without shadows that the environment light without shadows gave us this pass, and these are quite different. Now what I want to do is get these two passes to look as close as possible to one another as they can. And now this may seem counterintuitive, if you will, because we don't necessarily know that our environment light is giving us lighting that would match for our integration purposes. But there's a couple of trains of thought here. Firstly, I've found that the environment light does give nice diffuse lighting for integration purposes. Certainly a very good starting point. So matching that starting point is quite a good idea for us to get at least in the ballpark of where diffuse lighting should be. But also, in order to compare our shadows, we really need the rest of the lighting to be as close as possible. So we're simply looking at the shadows. And currently with the rest of the lighting being so far off, when we compare our two results, we can see that everything looks very different, and the subtleties in the shadows that I actually want to talk about, we're not going to be able to tell by comparing these two images. So if we look at our diffuse light and we look at our environment light without shadows, we can see that what we really need to do is decrease the contrast of this image so that our ground plane sort of comes back up in brightness and this very bright area gets pushed down a little bit in brightness. And then we need to increase the overall brightness of our image as well. So this is going to be just a couple of simple compositing operations. So I'm going to right click on the output of our diffuse light. I'm going to create a contrast cop. And I'm going to switch over to our scale tab. And I'm simply going to decrease the contrast to 0.4. So if we take a look now and compare these, you can see these are now closer in terms of their image, but this image is too dark. So if we boost its brightness back up by wiring into a bright cop. So there's our bright cop, no shadows, and let's bright shift by 0.2. We can see these are still slightly off, but they're fairly close. They're close enough that this is going to work for our comparison purposes. Now, if we were to recompare the multiply with our environment light without texture, notice that they're still very dark. It's still nowhere near what we're after for our environment light without a texture render. And there's another reason for this. Let's take a look at our ambient occlusion. Our ambient occlusion is quite a dark pass. We're multiplying it by our lighting, and at no point are we multiplying by a value of white. That means that every pixel of our final render is having the lighting attenuated, the lighting decreased by our ambient occlusion pass. So I want to ensure that the values in our image better represent a black through white range as opposed to a black through mid-grey range. And this is quite easy, again, through compositing. So I can simply wire our ambient occlusion into a new bright cop. And let's take that, and I'm going to set the brightness, say, to a value of 2, and that will just boost up the brightness. So our darks are still as dark as they were before, but now the highlights in our image get pushed closer to white. And if we now compare these two end results, we can see they are much closer to each other. There's some coloring discrepancies, and again, we can discuss why, but I mean, the big issue, rather than the coloring, because we can color correct in compositing, that's not such a big issue, is actually to do with the directional information. The most important factor in getting a pass right is going to be the directional information, because we cannot manipulate that in compositing. But it's going to be very hard to compare these values together, and actually, before I jump ahead of myself, I do want to also make sure that these values are still limited between 0 and 1, especially on the top end, because I don't want to multiply our lighting and make it any brighter with a shadow pass. The lighting should only ever be darkened by a shadow pass. So I'm going to wire the output of our bright cop into a limit cop, which is simply going to restrict the values between a value of 0 and a value of 1. And that just makes sure that in the very bright areas, if it was greater than a value of 1, it's now cut off, clamped if you will, at a value of 1, which ensures that we only ever decrease our lighting, we don't increase our lighting with our ambient occlusion pass. So we've got our result, but it's going to be very hard to compare side by side. What we really need to do is compare these over the top of one another and switch between them. So I'm going to wire the output of our multiply into a new switch cop, and then I'm going to take the environment light no texture and wire that into the switch cop. And if I was to set the input index to $F, our frame number, -1, that means that when we're on frame 1 we get a value of 0, and when we're on frame 2 we get a value of 1, which allows me with the arrow keys now to switch back and forth between these images. And I want you to pay very close attention to the area around the sort of lid of our teapot. Notice how that shadow seems to be shifting in direction between what we're getting with ambient occlusion and what we're getting with the area light. And again over here, notice how the shadow is far more directional. And on the ground especially, notice how the shadows are far more directional with our environment light, with our area light, over what we're getting with ambient occlusion. And that's because of the nature of ambient occlusion. Ambient occlusion gives us shadows that are very reminiscent of an overcast day, where the illumination is coming from all directions. And for many integration tasks, this may work very well. However, as we've seen when we were looking at the HDRI that we're using, our set had quite strong directional lighting, certainly a lot stronger than an overcast day has, because we've got the light entering the workshop area from those two ends, from the two sides. And that obviously is going to affect our shadows. It's going to give us stronger directional shadows than we get with an overcast day. And that means that in this case, our ambient occlusion pass simply doesn't give us the shadows that we need. So we need to modify our ambient occlusion pass to take into account our environment map, our Diffuse HDRI map, so that we can give us shadows that have a stronger sense of direction. Now, the result of this, however, is going to be that the diffuse light and shadows once again are combined into a single pass, as gets output by the ambient occlusion when we're using a map. This is something that we're going to see in a second when we implement this, and it's also something that is unavoidable. However, it's not actually a problem, and again we'll discuss that in a second, because we're not going to be replacing our current lighting pass and our current ambient occlusion pass with this new pass. It's going to be complementing our current passes, and we'll see exactly how that works in a second. For now, let's jump over into our shader. So I'm going to jump into our shader. Let's close down this network editor. There we go. And inside our shader, I'm going to Control-C, Control-V to create a copy of our ambient occlusion, which I'm going to rename to AO_with map. And I want to wire the output of this into our color so that we're seeing in our render the results of this particular node. Now what I want to do is I want to set the environment map of the AO with map to be our diffuse environment. Well, we already have that being specified as a parameter, so I can simply take the wire from our parameter and I want to wire it into the env map, the environment map input of our ambient occlusion. And that's going to use our environment. Now the environment object we could specify to transform our environment map into the correct orientation. By default, leaving it blank is actually going to give us the world space behavior that we require. So I'm actually going to leave this blank, and you're going to find that the environment map is oriented in the same orientation as for our diffuse lighting, and will be the same orientation as we'd use later on for reflections and the like. So everything is going to work out fantastically without specifying an environment object. So now if I was to render our scene, making sure I am looking through the camera, this is again an ambient occlusion pass, so it's going to take a little while to render, but if we were to re-render our scene, we should notice a couple of things. So let's just give this a second to render. The first thing you'll notice is that our ambient occlusion pass now has the lighting combined. It actually looks a lot similar to the environment light underscore no texture image that we rendered out from our environment light, because the lighting and shadows are combined. We can also maybe see, maybe not see, depending on what we're expecting to look in the image. This image does actually have that stronger directional shadowing, just like when we were using the area light. We can see there's shadowing here now on the spout of the teapot. Shadowing is pushed round to the side underneath the handle of the lid, and shadowing on the floor is offset more to the side to give us the idea that there's a strong light on this side illuminating our object from the side, obviously casting stronger shadows on the opposite side. So this pass has a lot stronger lighting in terms of directional lighting. So let's just let this render out, and then we can save it so that we can bring it back over into our compositing network. So there we go. So I'm going to save this frame, and I want to save this into S projects, HDRI shader, and I'm going to save this as AO_with map.pic. Save, OK. Minimize this, jump back over into the composite view, bring up our network editor, and let's send that over to look at our compositing view. There we go. Fantastic. And so we're looking at our compositing view, and now we can bring in our AO with map image. There we go. And I want to compare our AO with map with our env-light no texture. So I'm actually going to take this wire here and wire it into the AO with map so that we can use our switch to compare. There we go. So switching back and forth, you can see that with very little modification to that rendered pass, notice how similar these two passes are. We are getting the nicer shadows, if you will, in quotes, the shadows that I prefer at least, with our ambient occlusion calculation over the environment light, especially around the base of the teapot. So that's one advantage that we get. But you may ask yourself, well, what advantages do we get now from using ambient occlusion with our map? Because we're back where we started. We've got our lighting and our shadows combined in a single pass. But we mustn't overlook the real advantage here, that is everything is combined in a single shader. We don't have to create an environment light. We don't have to set up our environment light, manipulate that light to create passes. We simply have to switch an output, if you will, from our shader to get different passes. Again, we'll be dealing with setting up passes in a couple of videos time. But it's all encapsulated in a single shader. If we drop that shader into a network and use that shader, we get access to all of these passes. The other key element to make note is the fact that we are dealing with, in this case, a new pass that isn't intended to replace our ambient occlusion and diffuse lighting passes. In actual fact, the ambient occlusion with map, the diffuse lighting, and the ambient occlusion passes, all three of these passes complement each other. They work together to give us our final result. So let's discuss that now. So I'm going to take our ambient occlusion with map, and let's make that the only visible pass. There we go. So our ambient occlusion with map, we can really think of this as being the main diffuse lighting pass. In fact, I'm going to, from now on, when this is being output and we deal with render passes and passes being saved in terms of names in the images, this is our diffuse lighting pass from now on. This is the main pass for our diffuse lighting. But, as we've noted, it does contain both lighting and shadow information, and that doesn't give us all of the control that we'd like. So what we can do is we can take the ambient occlusion pass and the diffuse light pass that we had before, and we can use them to manipulate the overall lighting of our scene. So if we were to take our ambient occlusion, I'm actually going to take the brightened up and limited ambient occlusion. We can use this to manipulate and affect the general shadowing of our scene. Obviously, we're not having the true control of the directional shadowing, but we can affect the general shadowing of our scene. And this is very useful because we can basically increase the amount of general shadowing very subtly to just increase the shadowing if we need to match the background plate. Let's say the shadows in the background plate are slightly stronger than the shadow information that we have with our rendered image. We can just boost them slightly with the ambient occlusion pass. Or we can use the ambient occlusion pass to add some extra sense of depth into our renders. Let's say for whatever reason that the renders that we're getting back don't quite have the sense of depth that we were hoping for. We got multiple objects that are at different depths from the camera overlapping, but we're just not getting a sense of their overlapping, of the distance in depth between them. Quite often an ambient occlusion pass gives us the shadowing information between them that we need, that by bringing in a small amount of ambient occlusion we just start to increase the sense of depth in our render. So it can be very useful because of that. So what we can do, we can take a small amount of our ambient occlusion and we can multiply it in with our diffuse lighting pass. So I'm going to take our limit, and let's delete the multiply that we've got here. I'm going to take our limit, and if I was to basically blend this in with a white color, so I've got a pure white color, which I don't actually want to be wired into anything. There we go, a pure white color that I do want to make sure has the resolution of 634 by 475. Fantastic. That just happened to be the resolution of the other images I'm working with. And we can blend the ambient occlusion with that white. That allows us to go from no extra shadowing to full extra shadowing. Obviously we don't want to blend to black because that would shadow everything to nothing. We're dealing here with a white having a 0 effect and the ambient occlusion pass having full effect. And we can take that and we can multiply that in. Let's delete out that switch as well. There we go. Multiply that in with our diffuse lighting, and that gives us the ability, as I come up here and work with our blend, to say, okay, here's our original diffuse lighting because we've got white on our blend that's having no effect on our lighting. Let's actually show both of these together. And as we start bringing in ambient occlusion, we're going to start increasing the shadowing in our scene. And you'll notice, even though we're not having the directional shadows that we've got before, doesn't really notice too much in terms of our result. We're actually still getting a fairly nice looking set of shadows, and we're getting the ability to darken and work with those shadows independently. So that's kind of how the ambient occlusion pass works. The original diffuse light pass, what we can really think of as being, is a way of increasing the lighting in areas that are heavily shadowed, and really that's a fill pass, if you will. It's acting like a fill light. So we're going to be calling the light pass here that we have, which just has lighting information. From now on, we're going to refer to that as the fill pass. And that fill pass allows us to come in and just brighten up the areas that are heavily shadowed, maybe bring out some detail in the areas. If we had a large area that was all in shadow, we could bring out some of that detail, bring back in some of the different color information in those areas. And again, this is all about allowing us to match the lighting that's being captured on camera on our real set with our lighting. So if the lighting on set, the objects didn't have a lot of heavily shadowed areas, or they didn't, certainly in the area that our CG object is sitting in, didn't have a lot of heavily shadowed areas, then maybe we'd need to bring in a small amount of this fill pass to just match the diffuse lighting that we had with our background plate. In the same manner, if the shadows on the background plate were stronger than the shadows that we were dealing with our diffuse pass, then we need to bring in some of the ambient occlusion to match the background plate. And bringing in the ambient occlusion, we saw, was with a multiply. Bringing in our fill, it's as simple as adding in the result of our manipulation of that fill pass in with our final image. And we can see if we're adding everything in, we're getting way too much. So let's drop our background weight way down. So at a background weight of 0, we have no fill light. As we start bringing this in, we start increasing the fill light, we start bringing out some of those shadows areas. Now, simple situation like this, we really didn't have any overly shadowed areas, so we're not needing to really worry about fill light, but even a small amount of fill light could mean the difference between a very good integration with our backplate and a less or a slightly more poor integration with our backplate. Again, it's all about observing the backplate, observing the lighting in the backplate, how are the shadows working, how is the diffuse light working, what is the balance between the two, and by taking this raw pass that we have, which has all the information in, and then manipulating it very slightly with our fill and with our ambient occlusion, we're able to work our pass up to a point where it's as close as possible to what's happening in the backplate. So hopefully you can see from there the use of the 3 passes that we have: our diffuse lighting pass, our fill pass, and our ambient occlusion pass. So those 3 passes, their use, how they combine together. We multiply an ambient occlusion pass with our main lighting pass. We add in a fill pass on top of that to increase, just bring in some fill light. And also that hopefully explains why when we first covered these 3 passes that we were dealing with, why I didn't go into details over their uses, and that's because diffuse lighting and diffuse shadows is now broken down into 3 passes: our diffuse lighting, our ambient occlusion, and our fill. Now we are still going to be dealing with diffuse surface color. That is the final pass that we need to bring out the diffuse surface of this particular object, to specify, well, what color of lighting can we actually reflect in terms of diffuse lighting. And we'll deal with that in a couple of videos time. First, I'd like to deal with getting everything we have so far in our material wrapped up as an asset. And also I'd like to tackle how we're going to deal with multiple passes, because we already, in our shader, if I jump to our shader, we already have 3 passes being generated and no easy way to work with those passes. So I'd very much like to get that in place as well before we turn around and deal with the diffuse surface color. But again, I just wanted to recap. We have 3 passes being generated so far. We've got our diffuse lighting, which, let's jump over to the composite. There we go. We've got our diffuse lighting, which is actually coming from our ambient occlusion with map. We have our fill pass, and we have our ambient occlusion pass, and those 3 passes together give us the ability to specify the diffuse lighting of our scene. And with that, that is going to conclude this video. Thanks a lot, everyone.